Okay, this lesson is about algebraic expressions, and we're going to start off by talking about how to evaluate algebraic expressions. I'm going to define these three terms. You can see the definitions there so that we know we're talking about the same thing. A variable is a symbol, often x in algebra, sometimes y, sometimes a. It's any letter or symbol that represents one or more numbers. An algebraic expression is an expression that has one or more variables, so something like this. Okay, this is also an expression, but this is called a numerical expression because there are only numbers. This is algebraic expression because it has a variable. Evaluate means to find the value of an expression. So if I had that last expression and then I said evaluate this algebraic expression when x equals 2, that means plug 2 in for x and see what it would equal. This 4 is the value of that expression when x equals 2. So that's what I mean when I say evaluate. Okay, so evaluate this algebraic expression when a equals 3 and b equals -1. So find the value when these two things are the case. So I'm going to rewrite this algebraic expression, but this time instead of the variables I'm going to just put some open parentheses. Okay, so the first thing is a, which is 3, minus 2 times b, which is -1, plus 3, or a, times b, which is -1. So when you substitute in the value for that variable, we no longer have an algebraic expression. This is now a numeric expression. So a quick reminder of the order of operations. Sometimes people say PEMDAS, like this. It's a little bit tricky when you get to the multiplication, division, addition, subtraction thing. It's more like this. It's PEMDAS. Okay, and the reason why is you don't always do multiplication before division or addition before subtraction. You really do whichever one comes first, left to right. So parentheses, there's nothing inside of parentheses. That would be like if we had 2 plus 3, which we don't have anything like that. Exponents, no exponents, so then we go multiplication or division, and we go from left to right until we see multiplication or division. So we have multiplication here, so we do 3 minus 2 times -1 is a -2, plus 3 times -1 is a -3. 3 minus -2, this is really multiplication again, and so it would be 3 plus 2 plus -3. And that's the 3 and the -3 are going to cancel out, and we'll just be left with a +2. Yeah. So that's how you evaluate the algebraic expression. Okay, now we're going to evaluate an algebraic expression that has exponents in it. So again, I'm going to rewrite the expression, but instead of x this time, I'm going to do an open parentheses everywhere there was an x. Okay, so these are the two places there was an x. And I'm going to plug in the value 3 to find the value of the expression when x is 3. So substitute in x for 3, and then you do PEMDAS again. So first thing we want to do is parentheses, and we see we have an expression here with parentheses. So -3 squared minus 2 times 3 plus 1 is 4. Okay, next thing after parentheses is exponents. So we do have an exponent here. So we have -3 squared is 9. So we have -9 minus 2 times 4. Then the next thing we look for is either multiplication or division. Well, here negative times the parentheses, this is really like -1 times 9. So that would be -9. -2 times 4 is like -8. Now addition or subtraction from left to right, -17 is the value of this expression when x equals 3. Okay, example 3 gives us another expression, -0.3 y plus 61, and they say that models the percent of eligible voters who voted in the presidential elections from 1960 to 2000. Y represents the number of years since 1960. Find the approximate percentage of eligible voters who voted in 1988. So we want to figure out what is y. Well, y is the number of years since 1960. So from 1988 to 1960 is 28 years. If you subtract those, y equals 28. 28 years. So we're going to plug 28 in here to find the value of this expression. So negative 0.3 times 28 plus 61. Well, 0.3 times 28, what does that equal to? Let's just go ahead and do 3 times 28. So 28 times 3 is going to give you 84. And then remember it was 0.3 times 28, and so there needs to be one number behind the decimal point, so it would be 8.4. And since it was negative 0.3, it's negative 8.4. So we have negative 8.4 plus 61, or 61 minus 8.4. And that's going to be, so if I did 61 minus 9, that would put me at 52. So I don't go all the way to 9, so 52.6 should be the answer. Sorry for my crappy writing. Right. Okay, let's do a few more vocabulary terms because we're about to start simplifying algebraic expressions. So the term, coefficient, and like terms, this is what we're going to talk about. A term is a number, a variable, or the product of a number and variables. So this could be a term. This is a term. That's a term. 4xy squared, that's a term. Xy is a term. Okay, terms are each of these individual units. Okay, if there's multiplication going on, it's a term. If there's addition between it, we don't call that a term. So when I say a term, I mean these individual units. A coefficient is the number factor of a term. So let me bring this back. So this would be a coefficient. This is a coefficient. This is a coefficient. This is a coefficient. And then the coefficient here would be 1. Okay, even if I don't have it written out. So the coefficient is the number part of a term. Like terms have the same variables raised to the same power. So this is a like term with this. Same variable raised to the same power. Same variables raised to the same power, x and y cubed. So this and like xy squared, not like terms, because the variables have to be raised to the same power. So that's what a like term is. You might want to pause this and look through these. This is your algebraic properties, expressions. And this is what we mean when we say subtraction or division or division. Or each of these different things. Okay, so this is example 4, and we're going to combine like terms. Let me use the highlighter tool in a couple different colors. So like terms are things that have the same variable raised to the same power. So this has a z raised to the second power, and this term has a z raised to the second power. So those are like terms. Similarly, this has a z raised to the first power, and this has a z raised to the first power. So they're also like terms. So what we're going to do is we're going to add these two together. And the way you add them together is you add the coefficients. The sign that is in front of the term goes with the term, just like I've highlighted here. So 5z squared plus, I'm going to just regroup it, plus negative 8z squared. So I'll put this as a term. And then we're going to write it as plus negative 10z plus z. So we're going to add these two and add these two. 5 and negative 8 combine to give you a negative 3 z squared. So you add the coefficients together. And then over here you have negative 10 and a positive 1. When you add those together, you get a negative 9z. So another way you could write this is negative 3z squared minus 9z. That's simplified by combining like terms. Another example of this, so you still want to use the order of operation, so let's distribute this negative first, and you get negative n plus negative n plus 2m plus negative 6n. Okay, notice I'm still doing plus. You could write minus here, but for me it's easier if I write plus between each term. So now negative m and 2m, these are like terms right here. So I'm going to combine those. Negative 1 plus 2 gives me a 1m. Negative n plus negative 6n gives me a negative 7n. Negative 1 plus negative 6 is negative 7. So those combine, if you combine like terms, that's as simple as it gets. Okay, example 5. We're going to find the perimeter of this. So this is what we just did before, but now you're going to do it by finding perimeter. So go ahead and pause the video and try and answer this. And I'm going to go ahead and work it out. So there are a bunch of different ways to do this, but perimeter is adding up all the sides. So you could say a plus 2a plus, so you could say a plus 2a plus a plus 2a minus b over 2 plus b plus b plus b plus 2a minus b over 2. Okay, I've written every side out, and I started here and I just went around like that. That's one way to do it, and then you can combine like terms. And you'll get the right answer. But I think there's an easier way to do it. I'm going to just start by adding up like terms, all the things that have a in them. Okay, so these three are just a. So I could say a plus 2a plus a, and that's 1, 2, 3, 4 a's. So 4a. There are 3 b's. And then I want to add these two sides together. Okay, so if I add 2a minus b over 2 plus 2a minus b over 2, it's going to give me 4a minus 2b over 2. I can factor out a 2 here, and then that would give me 2 times 2a minus b over 2. This cancels out, and so I'm left with 2a minus b. Let me show you a shortcut for how to do that with these two problems. With that type of example. If I have 1/2 plus 1/2 and I add them together, I get 2 over 2, which is 1. That's what was on the top. Okay, so if I have half of it here and half of it there, then I have the whole thing here. If I have x over 2 plus x over 2 and I add them together, I get 2x over 2. I'm left with x. I had half of x from here, half of x from here, so they combine to give you x. No matter what you have on top, 3x squared minus 4 over 2 plus 3x squared minus 4 over 2. It's going to be 3x squared minus 4. I have half of it from here and half of it from here, so they're going to combine to give me what was on top. So if you take that, and you can see 2a minus b over 2 plus 2a minus b over 2 is just 2a minus b. That's what we got. Now let's combine 4a and 2a. That gives you 6a. 3b and negative b gives you plus 2b. So it's 6a plus 2b. The answer was C.